Welcome to our next demonstration. In this case, we're taking a look at the workshop that deals with subnetting. In this particular case, we're looking at an activity that you as a manager will never have to do, but we're considering it because it fits in with our discussion of network theory, how networks function, and also gives us a wonderful opportunity to demonstrate a possible question we might ask during an interview when looking to hire a network engineer, network analyst, security analyst, or other network monitoring sort of person. The skill with which the person can answer this question can give us a tool to use to measure their competence and experience level, or perhaps give some insight into the existing skill level of engineers that we have today. In order to consider it, we're going to take a look at an example using a couple of characters here. They're going to be the things that we use to measure against. And as we process the example that's given in the book, the example dealing with how to subnet this network right here, we're going to try to rate how well an administrator is answering that question. So is it someone that maybe I don't want to hire at all? Maybe someone who's not bad, maybe for a more junior position or possible entry-level position, or perhaps an outstanding answer, someone who I'd really like to hire right away. To deal with this, we have a couple of questions we're going to try to answer along the way, as we also talk about some of the theory that goes into subnetting. Now, one of the first observations that someone might make about this particular address, though it's not asked for, is that this is indeed a part of a private range of addresses, and you may also hear them say RFC 1918. That's just a fact to be aware of. Not a super important thing. They don't have to tell us that. And it's not actually the question we're asking. The question that's being asked, there's actually a few. The first question is, can you please tell me what is the current network and broadcast address for this network right here? Now, the network and broadcast address can be determined by taking a look at this piece of the address right here. This piece of the address or this entire address is written in CIDR notation, the classless interdomain routing notation, and the /24 is telling us how much of this address here is representing the network portion. And since it has a 24, it's saying that 24 bits of it would represent the network. That would be this part right here. So the network is the top 24 bits. Why am I saying 24 bits? Because each of the numbers here, the 172, the 12, the 18, and the 0, each represent just 1 byte each. Each byte, of course, is 8 bits, so that means that 3 bytes is going to be 3 times 8, 24 bits. So the network portion is 172.12.18. That starts to do the main part of the answer to these two questions. What is the network and the broadcast? Well, both of them begin this way, 172.12.18 dot. And I'll begin writing that for both of them. So let's say this is the net, and this is the broadcast. The difference between the two has to do with what happens in the host portion of the address. And the host portion is right here. Now, once again, the reason I know that's the host portion is that this 24 is telling me where the network portion is. That means that everything remaining, this byte, must be the host portion. That host portion represents a single byte. A single byte is made up of 8 bits. So if we were to think about that as bits, 2, 3, 4, 5, 6, 7, 8, if we were looking at a broadcast, the definition of that is that all of the host bits are turned on. On would be equal to a 1, so if these are all 1s, that is equal to 255 in decimal. That means that the broadcast address is 255. Now that, when we get to this point, you might look at that and say, oh yes, that looks very familiar to me. I've seen those before. The network address, on the other hand, is the opposite of that. The broadcast is where all of the host bits are 1. The net mask, or the network address, is where all of the host bits are 0. Now that's really easy to figure out. 0 is just 0. So the network address is here. The broadcast address is here. There is another question there, though. It also asks, what is the current network mask? Now, for a job candidate, they should immediately realize if they have already put the network mask over here by misreading the question or misunderstanding the question, they should immediately go back and revise this network address answer, because the network mask is something different. The network mask is, how can I write in decimal or using a mask something that will identify the whole network portion of an address? Now, when we were looking to find the broadcast address, we set these to all ones in the host. To find the network address, we set these all to 0. We're going to go a step further. To find the network mask, we take the network address and set all of the network bits to 1. So this /24 piece, the network piece, is all set to 1. So that would be 255.255.255.0. And again, that's another one that you may look at and say, oh yes, I've seen that before. I remember years ago when we had to set our addresses, we had to put a mask in and it always looked like that. Okay, so we have the first part of the answers. There's one last piece there that's a super easy one. This is really a gimme. It's much like the broadcast address. If it asks, what are the valid hosts? So the valid range of hosts on this network are going to be 172.12.18, the network address, dot 1 through 254. Why 254 and why 1? Well, the network address is 0, so that's taken, and .255 is the broadcast address. So the only thing left for hosts are 1 through 254. Now at this point, if you had someone who could answer all of those, I would probably put that someone around 4 or 5 so far. But if you had someone, for instance, who couldn't find the broadcast address or couldn't find the valid hosts, they are definitely sliding down toward a 1. If on the other hand, they didn't really know what the network address was, that wouldn't be super bad. They would still be rating around a 3 or a 4, probably not at a 5. Let's continue on to the rest of the question though. It now asks them to do something that any network engineer should be able to accomplish easily. It asks him to take this network and split it into 2 different networks. In other words, we currently have a subnet that has hosts 1 through 254. What I want to have is in this same set of addresses, 2 subnets where I can put a router between them. And I want to know what are the hosts, what are the network addresses, the network masks, and the broadcast addresses. Now in order to do this, we really only need to make one change over here to the CIDR notation. This is such a simple task because what we're asking to do is take the address 172.12.18 dot something, I'll leave it as a 0 for now, and we want him to take one more bit out of what is currently a host portion. Right now we have 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to go the other way because I'm running out of room. 1, 2, 3, 4, 5, 6, 7, 8. We have all of these bits, 24 bits, that are representing the network portion. That's what the CIDR notation is telling us. And then to the right of that, we have 8 more bits that are being used for the host. All we're asking him to do is to take one more bit and shift it into the network. That means that all that's happening here is this becomes a /25. And then he has to do some very basic math. Most of it doesn't change. For example, the beginning of these addresses will all be 172.12.18. They're all going to start that way. What comes after the dot is what's going to change. So I'm going to say there are 2 networks. I'll say that there is a low network. That's not an official technical term, it's just what I'm calling it. The low network is where all of the lower numbered hosts are, the initial range. For those, it's going to be .0/25. That address there is showing me also the network address. It happens to be the same. So I have the /25 and the network. What is the network mask? Now that's not terribly difficult either. Here we had 24 bits in the network mask. All we're doing is pushing one more bit. So we're still using all 24 of these. So the network mask will be 255, 255, 255. That's the same. We just need one more bit. Now the bits work out to be 1, 2, 4, 8, 16, 32, 64, 128. So dot 128 is going to be the network mask. Two last questions then. We know what the network address is, we know what the network mask is, we know what the network address is, and the /CIDR notation. We need to know the range of hosts and the broadcast address. The broadcast address is, again, the same definition, where all of the host bits are turned on. Now, in this case, the network address is here. So we're going to put in the network address, 172.12.18. Now really, this bit right here, which was previously in the host, is now in the network. That also needs to be left alone, and only these bits get turned on, these 7. What do those work out to when we convert it from binary into decimal? .127. That is the broadcast on the lower half of the network. Why? Well, because this portion, this little bit, you can imagine sitting there, that little bit is turned off because it's on the lower network, the 0 network. When we move to the 1 network, we'll see that changes. But before we do, let's also fill in the host range. It will be 172.12.18.1 through, now you could probably guess this. I can see that I'm using 0, and I'm also using 127, so it must be 126. That's not so bad. Now we do the same thing for the high address, which I'm also calling the 1 network, and I'll call this the 0 network. So with the 1 network, there's very little change. It still begins 172.12.18 dot, but now that bit is turned on, and we know from before that bit is worth 128, so 128/25 goes here. Now we need to know the network mask. It turns out the network mask is exactly the same because these two are actually using the same network mask. They're just changing which network they're on. So it is still 255, 255, 255.128. The next question is, what is the broadcast address? Well, the broadcast address is going to be this network with all the host bits turned on. That is almost the same as this. So we can start out 172.12.18. It's almost the same, except that now we're on the 1 network. That's the 128. So it's 128 plus 127, all the bits turned on. 255, a familiar broadcast. Finally, we need to know what is the range. The range will be 172.12.18. Now, we can cheat a little because we've already worked out the other problem, and we also know exactly where this network starts. This is the network address. So the first host is one more than that, 129, and the ending address is going to be 254. So this is our mask, the same. This is our broadcast, and this is our range. Now, what if you had someone that you were looking to hire as a network analyst or network engineer, and when you gave them this problem, they gave you all of these answers? I would probably be putting that person up over here. That is excellent. And as surprising as this might be, I can tell you that having done a lot of interviewing and hiring in the United States for network engineers, security analysts, network analysts over the last 20, 25 years, it is rare to have a candidate come in who can sit down and actually solve this problem. More often, the person is able to do some measure of it. So perhaps they can figure out a little bit of this top piece, but they're not really sure how to expand beyond this. Again, that's going to put this person down here around a 4 or a 5. Depending on how poorly they did here or how well they did here, they would be more toward a 5 or perhaps more toward the 1. On the other hand, as they begin to be able to solve this problem, that begins to move them above the 5. So that's excellent. I should expect they are able to do this, though it's not something they might do every day of their career. If they solve the whole thing, that's excellent. If they're able to begin working on it and perhaps they say, you know what, honestly, I'd have to sit down with a calculator, or I might be able to accept that. But if I asked that person to stand in front of a whiteboard, would I begin to see the kinds of things you see here, where they're now showing you, if you ask them, so what exactly is that broadcast? And they're saying, oh, that's where all of the host bits are turned on, or something to that effect. And here's what's going on with those 24 bits. The /24 is this. And when we add the /25, that's just taking in one more bit. So if they're able to do things like that, that is definitely increasing their score. Whether they solve the entire problem or not is actually not critically important to me. What's much more important is that their process of working through it demonstrates to me that they clearly know what they're doing. And that brings me to sort of the conclusion, the summary of this. Perhaps you're looking or asking this question: do you have to be able to solve the problem? Absolutely not. You know what the right answers are, and you should be able to tell if watching the person and asking them to explain it to you, it is clear to you that that person knows what they're talking about. That is actually the key that we're looking for. How much of the answer can you get? And how confident and how clearly do you understand what you're doing as you're working toward the answer, even if you don't get it 100% correct. If you have other questions and these types of tests that you do with possible candidates, please do share them with us. We're always interested in finding new things that we can add in order to give other people more of an ability to interview people successfully.